Okay, so we're going to start talking about, we're in Unit 3, the Intro to Probability Lesson 3, and the title of it is Independent Events. And you see it right there at the top, Independent Events. So we start talking about, it says, for the past two lessons, we've been finding probabilities for simple events. However, there are times when we may have to deal with probabilities involving two or more separate events. So we can talk this a little bit before we do the examples. So events are said to be independent if the occurrence of one event actually has no effect on the occurrence of the other. So for example, if you flip a coin 4 times in a row, that represents a series of independent events, right? The 4th flip or the 5th flip or the 500th flip, that isn't affected by the previous flip. All the flips are independent. Coins don't really have, well, they don't have memories. The first flip has no effect on the second flip. So that first example that we have on our sheet, it's example 1, a coin is tossed 4 times. What is the probability that the 5th toss you would flip heads? Well, it stays 1/2, it stays 0.5 because the previous 4 flips have nothing to do with it. That 5th flip is an independent event. The next part, it talks about linking a couple events together. So imagine a coin is flipped and a die is rolled. The question would be, what is the probability of flipping heads and rolling a 5? Well, clearly these are independent events as well. When you roll a dice and flip a coin, they don't affect each other in any way. They're independent. So I would let A be flipping heads and B be rolling a 5. Then our formula for this, our structure on it, is just the probability of A and B occurring. Because they're independent, is simply the product of the probability of A times the probability of B. So flipping heads is 1/2, and rolling a 5 on a 6-sided die is 1/6. So I go 1/2 times 1/6, that becomes 1/12. Example 3. A coin is tossed 6 times. What is the probability that all 6 tosses will be tails? So the probability, these 6 tosses, all tails, the probability of each one occurring is 1/2. So it's like the dash technique essentially. It'd be 1/2 times 1/2 times 1/2, 6 times, so it'd be 1/2 to the 6. Okay, example 4. Okay, a die is rolled and a card is drawn from a standard 52 card deck. What's the probability that a red face card, so a red face card, is drawn and a number greater than 2 is rolled? So a red face card and a number greater than 2. So red face cards, I have the 2 jacks, 2 queens, and 2 kings. So there's 6 red face cards over my total, 52. And then rolling a number larger than 2 on a 6-sided die, I could roll a 3, 4, 5, or 6. So 3, 4, 5, or 6. There's 4 options there and then 6 options total on the die. This reduces, the 6's would divide out, and the 4/52 becomes 1/13. Now for question 5, we're going to use a table. At an athletic event, athletes are tested for steroids using 2 different tests. The first test has a 93% probability of giving an accurate result. So I'm going to call this just test A, test B. Okay, accurate and not accurate. You have pass, fail, or success, fail, but I'll just say accurate and fail to be accurate, so not accurate. And the question tells us the first one is accurate 93% of the time. So if test A is accurate 93% of the time, that means it fails to be accurate 0.7% of the time, because 93 and 7 is 100%. That adds up. The test either works or it doesn't. You pass or you fail. So these two things have to total 100%. So if we're told it's 93, if it's accurate 93% of the time, it fails to be accurate 0.07% of the time. And then test B, it tells us it's accurate 87% of the time. So of course it would fail 0.13, 13% of the time. Okay. Part A says neither test shows that the steroids are present. Now it says if both tests are used on a sample that does contain steroids, so the sample has steroids, so it means that this test A will recognize it 93% of the time. It will be correct, and this one, it will miss it 7% of the time if there's steroids in the system. So quick A just says neither test shows that steroids are present. So that means because the question said steroids were present and neither test shows it, it just means the test failed. It didn't pick off the steroids in the sample. So this is really just saying what's the probability the two tests are not accurate and not accurate. So that's 0.07 times 0.13. Because the tests are independent of each other, we can just multiply them together to get our final answer. Part B says both tests show that steroids are present. So both tests work, they're successful because steroids are present. So it becomes 0.93 times 0.87. Multiply these two together to get that. And C is at least one of the tests detects the steroids. So at least one would be, okay, so this one works, that one fails, this one works and then fails, that one fails, or they both work. So the complement of at least one detecting the steroids is just part A, neither test detecting the steroids. So I just did the indirect method. I went 1 or 100% take away my result from part A to get my answer there. That's it. Try the posted questions.